Hi, I'm your mathematics tutor Mindy from Apex Tutoring. In these videos, I'm working through the 2019 HSC Mathematics Standard 2 exam. In the last video, we just finished up with question 30. So in this one, we'll be working through questions 31 through 36. Don't forget there will be timestamps for the beginning of each question in the description in case you want to jump ahead. Let's get started. Okay, question 31 says, a rectangle has a width W centimeters. The area of the rectangle A in square centimeters is A equals 2W squared plus 5W. The graph of A equals 2W squared plus 5W is shown. And then we have the graph. Part A says, explain why in this context the model A equals 2W squared plus 5W only makes sense for the bold section of the graph. So it's referring to this section of the graph here, which is bolded. And we need to give it a reason why, even though we can see this entire graph, that the model only makes sense for this bolded part. So we need to consider the context of the problem and what each of the prenumerals represents. W on the horizontal axis represents the width of the rectangle, while A on the vertical axis represents its area. A depends on W, the width of the rectangle. As the width changes, the area will change as well. Now, since W is the width of the rectangle, it would only make sense to consider positive values for W, and that's why we see the bolded area of the graph is where W is positive, and that's the only part of the graph we're going to consider as valid for this model. So we'll write the width must be a positive number. Okay. Part B says, the area of the rectangle is 18 square centimeters. Calculate the perimeter of the rectangle. So we're given the area, which is A, and we're asked for the perimeter. So to get the perimeter, we would need to know what the lengths of the two sides of the rectangle are, so that we can add up all of the sides. Now, if the area is 18, on the graph on the vertical axis, we'll find that here. And we can look at the graph to determine what the width of the rectangle would be. So we can see that the width, if the area is 18, is 2. So let's write what we know, that W is 2 and area is 18. Now, area would be calculated by taking the width times the length. If the width is 2 and we want to know the length, we can work it out since we know that area is 18. So the question becomes, 2 times what is 18? We can solve the equation by dividing by 2, or maybe you know that 2 times 9 is 18. So the length must be 9 then. And so we have a rectangle that has a width of 2, a length of 9, and we want the perimeter. So let's add up all the sides. Opposite sides are equal. So the perimeter will be 2 plus 2 plus 9 plus 9, which is 22 centimeters. And that's our answer. All right, let's go down to question 32. Question 32 says, the table shows the income tax rates for the 2018 to 2019 financial year. We have the tax table, and then it says the Medicare levy is calculated as 2% of taxable income. For the 2018 to 2019 financial year, Charlie pays a Medicare levy of $1,934.80. Calculate the tax payable on Charlie's taxable income. Okay, to work out the tax payable, we need to know the taxable income. The key to this will be the fact that the Medicare levy is calculated as 2% of the taxable income and is equal to $1,934.80. So that means 2% times the taxable income, I'll just write T for now, is equal to $1,934.80. We can work out the taxable income then by solving for T and dividing by 2%. So on the calculator, we'll do 1,934.80 divided by 2%, which you may also enter as a decimal 0.02. And we get $96,740. That's Charlie's taxable income. Now we can work out how much tax he needs to pay. So first we'll need to know which income bracket he falls into. $96,740 falls into the fourth bracket. So his tax payable is calculated as $20,797 plus 37 cents for each dollar over 90,000. Working this out, we usually start at the end. How many dollars over 90,000 is his taxable income? So we'll do 96,740 minus 90,000. So his income is $6,740 over 90,000. Now, we need to calculate 37 cents for each one of these dollars. So we'll calculate 6,740 times 37 cents. Make sure to put that in dollars and cents format so that our answer comes out in dollars. So let's do that on the calculator. And we get $2,493.80. Finally, he needs to pay the $20,797 plus what we just calculated. So let's add the $20,797. So we get $23,290.80 as his tax payable. And that's the answer. Let's go to question 33. All right, question 33 says, the time taken for a car to travel between two towns at a constant speed varies inversely with its speed. It takes 1.5 hours for the car to travel between the two towns at a constant speed of 80 kilometers per hour. Part A says, calculate the distance between the two towns. So this is a distance, speed, and time question, but also a question of inverse variation. Let's write down the DST triangle to remind ourselves of the relationship between distance, speed, and time. So the question being inverse variation and time varies inversely with speed, we could write T equals K over S. But when we look at the triangle and we see that T is D over S, we can realize that the constant of variation, which we sometimes call K, in this case is actually D, the distance. Now let's use the given information to find D. It takes 1.5 hours when we travel at 80 kilometers per hour. So we have 1.5 equals D over 80. We can solve for D by multiplying by 80, and we'll get D is 120 kilometers. Okay, part B says, by first plotting 4 points, draw the curve that shows the time taken to travel between the two towns at different constant speeds. Okay, so we need to pick a few different values for speed, get the time taken, and plot those as points. So let's check what we get when we travel 20, 40, 60, and 80 kilometers per hour. We could pick pretty much any speed we want to, but these four would be really easy to graph. So our equation is t equals d over s, but now we know that d is 120. So t is 120 over s. So when the speed is 20, time will be 120 divided by 20, which is 6. So at 20 kilometers per hour, it takes 6 hours, so we'll plot a point at 26. Next, when we have a speed of 40, the time will be 120 divided by 40, which is 3. So when we go 40 kilometers per hour, it'll take 3 hours. And we'll plot that point as well. Now let's try 60. The time would be 120 divided by 60, and that's 2. So when we travel 60 kilometers per hour, it takes 2 hours. Now let's get our fourth point and plug in AT. The time will be 120 divided by 80. I'm going to put this into a decimal so it's easier to graph. That's 1.5 hours, which is what we used in part A when we found D originally. So we can plot that. 80, 1.5 is around here. And that's 4 points, and now we just need to draw the graph. This is inverse variation, which graphs a hyperbola shape. This type of graph does not touch either the vertical or horizontal axes. It'll look something like this. And that will be our answer. Let's go to question 34. Question 34 says, the relationship between British pounds, P, and Australian dollars, D, on a particular day is shown on the graph. So we have a graph, and then part A says, write the direct variation equation relating British pounds to Australian dollars in the form P equals MD. Leave M as a fraction. Okay, this question is a little bit similar to the previous one, which was inverse variation. This one is direct variation. And the equation for direct variation would be of this form. Our first goal is typically to find the constant of variation. In this case, that is going to be M, by plugging in some given information. In this question, the given information can be this point on the graph here, 7, 4. That tells us that when D is 7, P is 4. So let's put that into the equation. And solve for M. We'll just need to divide by 7. M is 4 over 7, which we will leave as a fraction. Now we just need to complete the equation with M. P equals 4 over 7 D. Okay, part B says the relationship between Japanese yen, Y, and Australian dollars, D, on the same day is given by the equation Y equals 76D. Convert 93,100 Japanese yen to British pounds. Okay, while we don't have a formula to directly connect Japanese yen to British pounds, we do have one that will help us convert Japanese yen to Australian dollars, and then in part A, we can use our formula to convert that to British pounds. So, we have 93,100 Japanese yen So we can substitute that into y and find D, Australian dollars. So to solve for D here, we just need to divide by 76. We get 1,225 Australian dollars. Now we can use that in the previous formula from part A to convert that to British pounds. We have P equals 4/7D, which will be the 1,225. So on the calculator, 4/7 times 1,225 is 700. So the answer is 700 British pounds. Okay, let's go to question 35. Question 35 says, a compass radial survey shows the positions of 4 towns, A, B, C, and D, relative to point O. We have a diagram, and then it says, the area of triangle BOC is 198 square kilometers. Calculate the bearing of town C from point O, correct to the nearest degree. Okay, so we're looking for the bearing of town C from point O. The bearings of all the other points are given. For example, town A has a bearing of 29 degrees. We're missing the bearing for town C, but we are given the fact that the area of triangle BOC is 198 square kilometers. We should be able to use that information to find something missing in this triangle that will help us work out the problem. There are 2 options for the formula for the area of a triangle. For triangles like this one, where we don't have any right angles to work with, we can use the formula that's on the reference sheet. Let's take a look. So in the trigonometry part, we have this formula here. Area equals 1/2 AB sine C is useful for the area of a triangle where we don't have the base and height to work with. The formula requires 2 sides and the angle between them. We're given the area and we have 2 of the sides, which means we can use this formula to find the angle between the sides. This should help us to find the bearing as well. So let's call this angle C and the other 2 sides A and B and put the information into the formula. So we have area 198 equals 1/2 times A 25 times B 16 times sine of angle C. Just keep in mind, it doesn't matter which side is A and B as long as angle C is between them. So let's simplify what we have so far. I'll multiply these parts together first. So this simplifies to 198 equals 200 times sine C. We're trying to get to C, so let's divide the 200 across. That leaves us with 0.99 equals sine of angle C. Lastly, to solve for C, we'll need to take inverse sine of what sine C equals to. So we can get C by taking inverse sine with a little -1 on it, of 0.99. On the calculator, we get inverse sine by pressing Shift sign, and we'll put 0.99. So we get that C is 81.89 degrees. So knowing this will help us to work out the bearing we're looking for. As I mentioned, we do have bearings for the other points. We know that point B is at a bearing of 125 degrees from point O. And then if the angle from B to C is 81.89, we can just add that to the bearing of B to get the bearing of C. So we'll add 125 to what we got to get 206.89 degrees. We'll write what we did. And we want to round this to the nearest degree. So 206.89 would round up to 207. So our answer is 207 degrees. Let's go to question 36. Question 36 says, a small business makes and sells birdhouses. Technology was used to draw straight line graphs to represent the cost of making birdhouses, C, and the revenue from selling birdhouses, R. The x-axis displays the number of birdhouses, and the y-axis displays the cost/revenue in dollars. We have a graph, and then part A says, how many birdhouses need to be sold to break even? So to break even, that means your revenue and cost are the same, and you have made no profit but also no loss. We can see on the graphs that revenue and cost are the same at this point here. This point is where we have 20 on the x-axis. And as the question says, the x-axis represents the number of birdhouses. So when we sell 20 birdhouses, we will be breaking even. So that's the answer to part A. Now part B says, by first forming equations for cost, C, and revenue, R, determine how many birdhouses need to be sold to earn a profit of $1,900. Okay, well let's first form our equations. Let's start with C, cost. These are going to be linear equations since our graphs are lines, and the equation of a line is of the form y equals mx plus c. M is the gradient, c is the y-intercept. So what we're calling capital C for cost will be the gradient times x plus the y-intercept. So let's work out the gradient for cost. Gradient, m, is rise over run. So to work out the gradient from a graph, we need to find 2 points on the line and work out the rise and the run. So 2 points we can use here would be this point here at the beginning, as well as the break-even point. So from point to point, we'll be going up 3 ticks, which on this axis will represent 300, and across 20 ticks, which on the x-axis represents 20. So the gradient for cost is 300, the rise, over 20, the run. That simplifies to 15. So C equals 15x plus the y-intercept. The y-intercept is where the line crosses the y-axis, which we can see is 500. So we have capital C equals 15x plus 500. So that's the equation for C, the cost. Now let's find the equation for R, the revenue. All right, R equals, and it's also a line, so it's going to be the gradient x plus the y-intercept. So once again, we'll look for 2 points on the revenue line. So once again, we can use the point at the beginning and the break-even point. So from point to point here, we're going to be going up 8 ticks. That is 800 on this axis, and across 20, which again is 20 on the x-axis. So the gradient is 800 over 20, which is 40. So R equals the gradient 40 times x plus the y-intercept. We can see that for the revenue line, the y-intercept is 0. We could write plus 0, but we really don't have to write anything for that. We would normally just write R equals 40x. Okay, now we have our equations for C, the cost, and R, the revenue. And we need to work out how many houses need to be sold to earn a profit of 1,900. So if we think about it, profit is your revenue minus your costs. So that means that profit would be revenue, as in 40x, minus our costs, which is 15x plus 500. It's important for me to write brackets around where I put the cost equation, because there's 2 terms there to be subtracted. We'll simplify that by expanding the minus through the bracket and combining like terms. Now we have an equation for profit given x, the number of birdhouses sold. So now we just need to set this equal to 1,900 and solve for x. So I'll first add 500. So next we get 2,400 equals 25x. And lastly, we just need to divide by 25. On the calculator, I can do 2,400 divided by 25 to find that x equals 96. So that means that if we sell 96 birdhouses, that we'll have a profit of 1,900. So 96 is the answer. So we'll take a break and stop there, and in the next video, we'll pick up with question 37.